This video is on operating with radicals. We're going to be doing some examples with operating with radicals. We're going to be potentially adding, subtracting, multiplying, and dividing. Our first problem here says the square root of 75 divided by the square root of 3. So this is division. So again, with division, with all of these, we have to have the same index. So these are both square roots. With adding and subtracting, they have to have the same radicand. With multiplying and dividing, they do not. So with division, we do want to see if we can simplify this before we try and rationalize the denominator. We cannot have a radical in the denominator, so let's see if we can simplify this. Because these are both radicands, I can try and divide these two numbers. So 75 divided by 3 is actually 25. So this becomes, I have to keep the radical, the square root of just 25. So this becomes a much easier problem than if I were to try and rationalize. So the square root of 25 is just 5. And that's our final answer for this first problem. It might look difficult, but a lot of times the problems are you can simplify ahead of time and it becomes much easier to deal with. Instead of having to multiply by the square root of 3 to top and bottom and then simplify, see if you can simplify first. On the second problem, we're going to try and do the same thing. This is a division problem. We have a square root and a square root. Our coefficients are both 1, so we can only focus on the inside. So focusing on the inside, radicand, radicand. See if this will simplify to something smaller. So we have the square root of 54 divided by 2 is 27. So this will become, we know it's going to become the square root of 27. So far that's going to be in our numerator. X to the 5th divided by x squared is x cubed in our numerator. And y divided by y goes away. So y divided by y is just 1. So this would just be times 1. So we can end that. Now this is all in the numerator now, so we do not have to rationalize the denominator. We just have to simplify. So if we go back to understanding how to simplify radicals, we simplify the number, then we simplify the letter. So the number, square root of 27 will become 3 square root of 3, because it's 9 times 3. Square root of 9 is 3, and we're left with the radicand of 3. For x cubed, the square root of x cubed, 2 will go into 3 one time, so we'll have x to the first power, but we will have a remainder of 1 left over. So now to put it all together, our coefficients are 3 and x, and then our radicands, so we have a square root of 3x again. And this is our answer. On the next problem, we do have the same radicals. We have the same indices, so we can simplify. But as we can see, we do have parentheses squared and parentheses to the 4th power. So you could distribute this and become 2x times 2x, which is 4x squared. And then we would have 5 to the 4th and y to the 4th as well. Or you could try and simplify this beforehand. So if you actually look at this problem as this is the square root of something squared. Well, anytime you have the square root of something squared, those will take each other out. Those are inverses of each other. So whatever I have inside the radicand will be what's left. So the square root of this squared, those will go away. So I will actually just have the 2x in the numerator, because that's what, if you see, that's what I'm covering up. Whatever I'm covering up in the numerator is going to stay there, because the square root and the square will cancel each other out. So I actually have just 2x in the numerator. For the denominator, so focusing on just the denominator, if I cover this part up, I have the square root of something to the 4th power. Well, since it's the square root of something to the 4th, 2 goes into 4 2 times, so my index will go into my exponent 2 times. with no remainder. So there will be no radicand. There will be no radical in the bottom. So I could actually have in the denominator, I'll have whatever's in there. So I have 5y. But to the coefficient, so that's our coefficient, raised to the exponent of 2 goes into 4 2 times. So my exponent will be 2. And there is no radicand. So actually there are no more radicals on this problem. All we need to do is just simplify this to see if anything can simplify further. So the numerator is 2x. The denominator is 5y squared. So this becomes 5 times 5 is 25. And y times y is y squared. So if we look at this problem, our coefficients are 2 and 25, which cannot be simplified. Our numerator has an x. There's no other x in the problem, and it has a positive exponent, so that's good. And then in our denominator, we have y squared. There are no other y's in the problem, and we do have a positive exponent. That means that our answer is actually just 2x over 25y squared. We could have distributed this and become 4x squared and then 5 to the 4th over 5 to the 4th, y to the 4th, and then simplified that, which would have gotten to the same ending. It just would have taken much longer. On number 4, we have the square root of xy and the square root of 3x. Therefore, we can simplify because we have the same square roots. We're dividing so they don't have to have the same radicands. So we look to see if there's anything we can simplify before we have to do anything that will take longer. We have an x in the numerator and we have an x in the denominator. Well, x divided by x will go away. So we're left with y in the numerator and 3 in the denominator, both underneath the square root symbol. So we have the square root of y over the square root of 3. Because the x's will go away because they're both inside the radicands. Now, these cannot simplify further, so I do want to keep them separated. If you can simplify them, you would want to put them together, just like we could do here. 54 over 2 in one radical gave us 27. But y and 3 won't simplify together, so keeping them separate will help us to know when we have to rationalize the denominator. So this one, we will have to rationalize the denominator. I'm going to write a note, rationalize the denominator. Again, we want to rationalize the denominator because we do not want a radical in the denominator. So I'm going to rewrite this problem down here. We have the square root of y over the square root of 3. We want to make the denominator a rational number. So we focus on the denominator. In order to get the square root part gone, we want to multiply, or we want to square a square root to get rid of the square root. So to square something, we would multiply it by itself. So we would multiply the denominator by the square root of 3. Now, as long as we keep the value the same, we're allowed to do this. So what can we multiply by to keep the value the same? The only thing, the identity property in math for multiplication is if you multiply by 1, the value stays the same. But we already have the square root of 3 as our denominator. That means in order to make this a value of 1, anything divided by itself is 1. So it's already being divided by the square root of 3, so the numerator also has to be the square root of 3. So now we can multiply. This will give us the square root of y times square root of 3 is equal to the square root of just 3y over, divided by, the square root of 3 times the square root of 3 is just 3, because this becomes square root of 3 squared, and you're just left with the radicand. And this is our final answer. Because now the coefficient is a 1/3, a 1 in the numerator and a 3 in the denominator. Our radicand is 3y, which cannot be simplified. and the 3 in the radicand and the 3 in the denominator cannot simplify together because one is a radicand and one is a coefficient. These are the first 4 examples.